Hey everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into multi-stage PCY algorithm, which is a refinement for PCY algorithm. In one of the previous videos in the bit data analytics playlist, we already have seen what exactly is PCY algorithm, that is the Park-Chen-Yu algorithm. If you haven't watched that particular video yet, please go and watch that in the bit data analytics playlist from our channel. Now, first we'll have a look at why exactly we need to use multi-stage PCY algorithm. So basically, here are the points that I have listed. The first reason to use multi-stage PCY algorithm is more hash tables. Yes, multi-stage PCY algorithm uses more number of hash tables than the PCY algorithm. In the PCY algorithm, we only used one single hash table. Now, what is the use of using this more number of hash tables? It will help us to reduce the number of candidate pairs. That means while finding out the candidate pairs, there might be a chance that the candidate pair might not be a frequent pair. That means it can be a false positive case. So in that particular case, this more number of hash tables will help us to reduce those false positives. Now, multi-stage PCB algorithm contains additional passes. Now, the use of this additional passes is to refine the candidate pairs more effectively. That means we are going to use the most efficient way of finding out the candidate pairs. Now, how this additional passes approach is effective, we can understand this by looking at the example that we are going to solve in this particular video afterwards. Now, the third reason why to use multi-stage PCY algorithm is the memory utilization. Yes, in multi-stage PCY, the bit vectors eventually consume all of the main memory. This is a trade-off for the increased accuracy in candidate pair selection. So here we are going to use the best of the memory that is allocated for our task. That means unlike in a priori or PCY algorithm, we are going to use the entire memory that is allocated for our task effectively and efficiently. So these three are the reasons for using multi-stage PCY algorithm. Now we'll have a look at the diagrammatic representation of the main memory that is going to be used while solving or while using the multi-stage PCY algorithm. So you can see, as I already said, it contains more than two passes. So this is the pass one. In the first pass, we are going to find out the item counts. That means for each and every unique item, we are going to find out its frequency. Then we'll create the first hash table. We'll hash the frequent pairs. Then in the second pass, we are going to create frequent items out of the item counts which supports the minimum threshold condition. And we are going to map the first hash table into a bitmap in the second pass. Now, instead of counting the total number of candidate pairs, we are again going to use one more hash table. That is the second hash table. The use of the second hash table is to reduce the number of candidate pairs. That means the second hash table will make sure that no more number of false positives will be present inside the set of candidate pairs. Now, once this pass 2 is done, we are going to move to the pass 3. And in this pass 3, we will be having our frequent items, then the bitmap, that is the first hash table map. And then we are going to also map the second hash table to a bitmap. So there will be in all two bitmaps, and this bitmaps will contain the history of the entire candidate pairs which were actually extracted from the previous two passes. And then finally, we are going to count the total number of candidate pairs which are actually frequent. And trust me, this particular set of candidate pairs will have the minimum number of false positive cases. So this is the main memory representation of multi-stage PCY algorithm. It is better, far better than the PCY algorithm. No doubt you can use more than three passes also, but make sure that you use appropriate number of passes, because as and when you increase the passes, there is a chance that you get negative results. So instead of using more number of passes just to get rid of all the false positives, we can use ample number of passes and can get better results than the normal PCB algorithm that we use. So I hope the memory representation of the multi-stage PCB algorithm is clear to you all. Now we'll move on to the algorithm. So basically how this multi-stage PCB algorithm works, we'll have a look at it. So this is the algorithm. And in this algorithm, you can see that there are total three passes. So the first pass says that we need to count the items. That means we are going to first calculate the frequency of every single unique item and we'll see first that whether they satisfy the minimum threshold condition or not. And if they satisfy the minimum threshold criteria, then we are going to hash them into pairs, that is pair of I and j, where I is one item and j is another item. And we'll make sure that item I and item j both are frequent. So once pass 1 is done, we'll get one hash table. Now, once this is done, we'll get into pass 2. So now inside the pass 2, we'll have to check certain criteria. So what is that criteria? So here we are going to check two conditions. First condition is that the item I and j in the frequent pair that we have got in the past one, they both has to be frequent, which we have already seen in past one. And the second criteria is that the pair that has got formed from these two items, it hashes to a frequent bucket in B1. That means whatever buckets we have created with the help of the hash function that we have used in the past one, the buckets has to be frequent. That means whichever bucket this particular pair is in, that bucket has to be frequent. And if that bucket is frequent, then only we have to move to this particular step. That is, we are going to hash the same pair into a new hash table. So basically, if these two criteria are actually getting satisfied, then only we'll hash the pairs into a new hash table. Otherwise, we won't. We'll discard them. Now, once the second hash table is created, we'll move to the pass 3. Now, inside the pass 3, again we are going to check three conditions. Here you can see that the first two conditions are the same as we have seen in pass 2, that is I and j. Both the items has to be frequent in number, and then whichever pair they have created from the item I and j, they must hash to a frequent bucket in B1, that is from the first hash table. And the third condition is that the second hash table that we have created, that is from which we have got the bucket B2, that particular bucket also has to be frequent for this particular pair. If these three conditions satisfies, then only we'll count them as a candidate pair. That means if three conditions are getting satisfied in pass 3, then only we'll say that I and J are candidate pairs. Otherwise, we will say that they are not candidate pairs. So this is how the multi-stage PCY algorithm works in three passes. So I hope the thing is clear. I'm sure that by looking at this particular algorithm, you might have got a simple picture of how this particular algorithm works. And yes, I'm also sure that everything has not got cleared, but yes, we are going to look into one example which will clear all your doubts. And trust me, this particular example is nowhere available. I have done a lot of research in designing this particular example. So please, if you are looking at this particular video, then please first like it. And if you are new to the channel, please subscribe it. So now let's have a look at the example. And this is the example that we are going to look. So you can see in this particular example, we have total 5 baskets. Each basket is having certain elements inside it, or we can say certain items inside it. For basket 1, you can see apple, banana, mango is present. For basket 2, apple and orange is present. And similarly, basket 3, basket 4, and basket 5 also contain certain items. Now, here there is a condition given that minimum support count is 2. That means at least this many number of pairs has to be present inside the transaction list so as to make it frequent. Now, the thing I have done here, just to increase the simplicity, I have replaced each and every item's name by its first letter in capital. Now here, if we look at apple, I have replaced it with capital letter A, that is the first letter of apple. Similarly, for banana, I have written B. For mango, I have written M. And for orange, I have written O. Now, if you look at the algorithm carefully, here you can see that in pass one, we have to count the items. Now, it states that we'll have to find out the frequency of every single item that is unique. Now, inside our transaction list, we have total 4 unique items, that is apple, banana, mango, and orange. In this case, it is A, B, M, and O. So let's write all the unique items, that is A, B, M, and O. Now we'll have to count the frequency of all these unique items. So for A, we'll have to check how many times A has got repeated in the entire transaction list. So you can see A has got repeated 1, 2, and 3 times. Similarly, we'll have to check for B. It is repeated 1, 2, 3 times. For M, it is repeated 1, 2, 3 times. And for O, it is repeated only 2 times. So we'll write 2. Now, once we have written the frequency of every single item, we'll have to check whether each and every item is following this minimum support count, which is 2. So you can see in the entire list of unique items, every single item is satisfying the minimum support count. That means every single item's frequency is greater than or equal to 2. That is why all these items are eligible. Now, one thing we have to do is that we'll have to convert all these items into numbers. Now, why we are converting it into numbers? Because we are going to use hash functions, which will take integer as an input and it will process it to produce an output. So that is why we'll have to convert all these unique items into unique numbers. So let's give them numbers. So let's say A is represented by 1. Let's say B is represented by 2. Let's say M is represented by 3 and O is represented by 4. Now once this is done, the next step is to hash all these frequent items into pairs. Now, make sure that whenever you are hashing items into pairs, you should check the criteria whether each and every item is following the minimum support criteria or not. So I hope this thing is clear. Now we'll hash all these items into pairs. Now, for that, we'll have to first construct a hash function. We can use any hash function. Here I am using one hash function. Let's say it's hash1 and the hash function is defined something like this. It is I plus j. Now what is I and j? I is the first item and j is the second item in the pair. I plus j modulo 3. Now modulo is an operation. It is nothing but whenever we divide this particular term from this, whatever remainder we get, that is nothing but the result of the modulo operation. So I hope it is clear. So this is our first hash function that we are going to use in the pass one. Now we'll have to create pairs. Now how pairs are created? We'll have to check each and every basket for creating the pairs. So you can see if you look at basket 1, here in basket 1 there are total 3 items, that is A, B and M. We'll have to find out each and every possible combination of these 3 items A, B and M. So here you can see first pair can be AB, the second pair can be BM and the third pair can be AM. So similarly we have to create pairs from all the list of baskets. So let's write our very first pair, that is AB, which is from the basket 1. Now from the basket 1 itself we have one more pair, that is BM. The third pair from the basket 1 is AM. Similarly, we can have pairs from the other baskets also. So here you can see in the second basket we have the items A and O. Here we can have only one possible pair, that is AO. So let's write it. Now if we look at basket 3 we have the pair B and M. So here you can see BM is already one of the pair that we have created already. So let's skip this. Now let's move on to basket 4. Here the pair is AB. AB has already been a part of our list of pairs. Now let's move on to the last basket. Here you can see MO is the pair which has not got repeated yet. So let's write MO. So these are all 5 pairs that we have created and all these pairs are created from frequent items only. Now, if you remember, we have converted every single item into its unique number. So let's convert all these pairs in the form of the numbers that we have assigned to every single item earlier. So if you look, AB can be replaced with 1 and 2 because A is having the value 1 and B is having the value 2. So we can write 1, 2. For BM, it is 2, 3. For AM, it is 1 and 3. For AO, it is 1, 4. And similarly, for MO, it is 3, 4. So I hope this thing is clear. Now we'll have to use this particular hash function. We have the value I and j. We'll have to calculate the hash value of every single pair, starting with this particular 1 and 2. So let's write 1 plus 2 modulo 3. Now, after calculating this, we get the answer as 0. Why? Because 1 plus 2 is 3 and 3 modulo 3. When we divide 3 from 3, we get the remainder 0. Similarly, we can have 2 plus 3 modulo 3, which gives us 2 as the answer. Similarly, we can have 1 plus 3 modulo 3. It gives us 1 as the answer. Now, for this particular pair, 1 and 4, we can have 1 plus 4 modulo 3, which gives us 2 as the answer. Similarly, for this particular pair, we can have 3 plus 4 modulo 3, which gives us the answer as 1. So you can see we have got the hash value of every single pair. Now, what exactly is this hash value? This hash value is nothing but the bucket number in which the item or the pair is going to fall. So, for pair AB, it is going to be a part of bucket 0. For pair BM, it is going to be a part of bucket 2. So, by looking at this particular 5 hash values, we can say that we have total 3 buckets. That is bucket 0, 1 and 2. So let's write it. And here we have bucket 2. So you can see that our bucket 0 contains only one single pair because there is only one pair AB whose hash value is 0. So therefore, we'll be having only one single pair in bucket 0. Similarly, if you look for bucket 1, we can have in the calculation that we have got, there are only two pairs whose hash value has got 1. So we'll write that in bucket 1, there are two pairs which will be located inside bucket 1. Similarly, for bucket 2, you can see there are two pairs whose hash value has got 2. So this is the final result. Now, by looking at this particular set of buckets, you can see that a bucket is said to be frequent only if it contains minimum support number of pairs inside it. That means in our case, if a particular bucket is having at least two pairs inside it, then only that particular bucket will be called as a frequent bucket because our support count is 2. Now, by looking at all these three buckets, we can say that bucket 1 and 2 are only the frequent buckets because we are they are actually satisfying the minimum support count. So 1 and 2 are the frequent buckets. So this was our pass 1. So I hope it is clear that what exactly is done in pass 1. So I hope the pass 1 is clear to you all. Now let's move on to pass 2. So basically inside the algorithm, if we look in the pass 2, we'll have to look at two conditions. First condition is that the pairs that we are going to look for, each item in that pair has to be frequent. And the second condition says that whatever pair we are talking about, it has to be hashed to a frequent bucket. So we already have found out whether that particular item is frequent or not, and we already have found out whether that particular pair belongs to a frequent bucket or not. So let's try to hash the pairs which actually satisfies these two conditions into a new hash table. So let's do that. So now we are going to talk about pass 2. So in pass 2, we have to take those pairs which actually satisfies these two conditions. Now, if you look carefully, at the buckets. From these buckets, we have found out a conclusion that only bucket number 1 and 2 are frequent, and the pairs that are located inside the bucket 1 and bucket 2 are only satisfying both the conditions. So, these are the pairs which are under the bucket 1 and bucket 2, that is BM, AM, AO, and MO. So only these pairs are going to be a part of pass 2. We are going to exclude the pair AB because it is not a part of the frequent bucket, that is the bucket 0. So I hope it is clear. So let's take all these 4 pairs to the pass 2. So let's write BM, then we have AM, then we have AO, and lastly we have MO. Now we will write the number representation of all this. So BM is 2, 3, AM is 1, 3. Similarly, we have AO as 1, 4, and we have MO as 3, 4. Now, what we need to do in pass 2, we'll have to use a new hash function for mapping all these pairs to a bucket value. So we'll have to construct a new hash function, and let's say the name of the hash function is hash2, and this time we are taking a function I multiplied by j modulo 3. So this is the hash function that we are going to use for every single pair to find out its hash value, and that hash value will decide in which bucket that particular pair will belong to. So let's start with the pair BM, which has the value 2, 3. So here you can see that it gives us 2 into 3 modulo 3. So 2 3s is 6, 6 modulo 3 is 0. So BM pair belongs to bucket 0 this time. Next, 1 3. 1 multiplied by 3 modulo 3. It gives us the value 0 again. Similarly, let's move on to the next. 1 multiplied by 4 modulo 3 gives us 1. That means the pair A0 belongs to first bucket. Next, we have the pair 3, 4. So 3 into 4 modulo 3. This gives us 0. So from all these pairs, we can see that 3 pairs belongs to bucket 0 and only 1 pair belongs to bucket 1. So you can see, so you can say that we have 2 bucket, that is bucket 0 and bucket 1 this time. And we can say that bucket 0 has the pairs AM, then BM and MO. So from this, you can say that there are total 3 pairs that are part of bucket 0. For bucket 1, we have only one pair, that is A0. So that is why we'll write that is only one pair is present inside bucket 1. So now you know that the minimum support criteria is 2, but here for bucket 1, it is having only one single pair, which doesn't satisfy the minimum support criteria. That is why we'll exclude this particular bucket 1, and all the pairs that are present inside the bucket 1 will be excluded. Now, bucket 0 is having 3 pairs. That means it is satisfying the minimum threshold condition. That is why this particular bucket is said to be a frequent bucket. And all the pairs that are present inside the bucket 0 are going to be frequent. Now, if you look carefully at the bucket 1, it is excluded. Now, the pairs that are present inside it is AO. You can see that AO pair is also excluded because its bucket is excluded. Now, let's see whether AO was actually frequent or not, whether the multi-stage PCY algorithm is giving us wrong results or not. If this particular AO pair is frequent from the list of transactions, then we'll say that multi-stage PCY algorithm is wrong. Otherwise, we'll get a proof that how it works, how it removes the false positive. Let's see whether AO is the false positive case or not. So in the transaction list, you can clearly see that AO is repeated only one time in the entire database. Our minimum threshold condition is 2. If AO was repeated at least twice, and then also if we have got AO getting ruled out from the multistage PCY algorithm case, then we could say that multistage PCY was going wrong. But here you can see that AO is actually not frequent, and multistage PCY, with the help of hash functions, it has ruled this out. So this is how it works. This is how multi-stage PCY algorithm is better than PCY algorithm. It actually removes the false positive. It reduces the number of false positive cases from. So now that we are done with pass 2, let's now move on to pass 3. So if in the algorithm, if we look, you can see that inside pass 3, we'll have to check for three conditions. The first condition and the second condition is same as that of the conditions that were specified in pass 2. That is, the items which are present inside the pair, both of them has to be frequent. The second condition says that the pair that we are talking about, it has to hash to a frequent bucket in the first hash table. And now the third condition is specified in such a way that the pair that we are talking about, it has to hash to a frequent bucket in the second hash table. So we already have calculated the second hash table in pass 2, and we also have created the buckets. We also have seen which bucket is frequent. And now in this pass 3, if these three conditions are getting satisfied, then we have to count that particular pair that we are talking about as candidate pair. So now, as we have seen that these three are the pairs which are involved in the bucket 0, which is considered to be frequent. Let's talk about pass 3 now. Let's take all these three pairs in pass 3. So first pair is AM, the second pair is BM, and the third pair is MO. So let's check for AM. You can see that A and M, both of these items which are present inside this pair are frequent. A has the count 3 and M has the count 3, which says that it is satisfying the minimum threshold criteria. And according to the second condition, it hashes to a frequent bucket in the first hash table. So you can see that AM is the part of frequent bucket. That is why it was eligible. And according to the third condition, AM hashes to a frequent bucket in the second hash table. So you can see over here in the second hash table also whatever buckets we have created, the pair EN is situated inside the bucket 0, which is frequent. So all these three conditions are getting satisfied for all these three pairs. Similarly for BN and MO also. So these are the finalized pairs, and we can say that these are the selected pairs at the end of pass 3, and we can say that these three pairs are nothing but candidate pairs. So this is how the multi-stage PCY algorithm works, and it helps to finalize the frequent pairs. Now also note one thing, that it is important to choose the best hash function because your result will be dependent on hash functions too. So it is advised to use an appropriate hash function. And one more thing to note is that the whatever hash functions you are using, for example, in pass 1 we have used this particular hash function I plus j modulo 3. The hash function that you are using in the next pass or for finding the second hash table, that hash function has to be different from the previous hash function. It has to be independent from the previous hash function because if you take the same or if you take a dependent hash function, then in that case, your result might not be the correct one, or you might get the same pairs in the same bucket. So I hope each and every pass in this particular algorithm is clear to you all. If you guys have any single doubt, you can straight away put it in the comment section. I'll be happy to solve it. If you like this particular video, please do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Also, don't forget to join me on Telegram.